All right, folks, today I'm going to walk you guys through, we're going to do a video lab on pendulums. So I just want to refer back toward the beginning of the notes. This is kind of what we started out with when we were talking about waves and simple harmonic motion. So just to review some of the basic concepts, go along with the variables and their mathematical equation, talk about some of the things we can change and how those variables may affect the performance of a pendulum. It goes something like this. So we did say that a pendulum is basically just a mass suspended by a spring, and it can oscillate back and forth, kind of like an old grandfather clock, or maybe someone on a swing set or something like that. And our variables, along with this equation, we were looking at the time, which is also known as the period, so how long it takes to oscillate from one point back to that same location, going from one side all the way back and forth. The 2 pi here is just a fixed value, and then you got L and you got G. So L is the length of the pendulum, and that's measured from the point where it's suspended to the center of wherever the mass is. So if you're oscillating like a big beach ball or something, the distance has to be measured to the center of the object or the center of the mass. And then the G, the lowercase g here, has to do with the acceleration of gravity. So just by looking at this, and I don't want to give too much away because there's 3 separate experiments in the Pendulum Lab. We're going to be looking at the relationship between the mass that's suspended, we're going to look at the length of the pendulum, and we're also going to look at the release angle, or like the amplitude of how far we pick this up and let it go. So I'm going to scoot ahead here. You guys will have a printable version of this that you can print off, and you guys are going to want to write your hypothesis down for this as you go along, and also you're going to have some data to put in the data tables and a graph to make, and then you'll have multiple ways you can submit this, which you'll see as we go. So the Pendulum Lab itself, I state some basic problem, and it's just asking what are the factors that affect the swing period of a pendulum. So again, we're talking about how long it takes to make full oscillations from one point back to that same point in the oscillation. Kind of like when we talk about waves, you can measure, the period of a wave from measure the wavelength from the peak to the peak, or the trough to the trough, or any common point along that wave. Kind of similar with the pendulum. If we pick the pendulum up to the right and release it, it's the time it takes to return back to the same location. So we're looking at what affects that. Hypothesis number 1 says, as the weight of the object, or mass I should say, as the mass or weight of the object is increased, what will happen to the period? So we'll be changing the amount of washers or rings that we put on this hanging mass, and of course the mass and the weight is dependent on gravity, your acceleration of gravity. So we're going to stay on Earth, so we will be changing the mass and the weight, but it's all under the influence of gravity, so we're not going to change the acceleration 9.8 meters per second squared. That's going to stay the same. So as we increase this, what's going to happen to the period? Do you think that as the mass gets heavier, it's going to oscillate slower? Do you think it's going to oscillate faster? Or do you think it's going to be unchanged? Maybe you don't think it will change at all. Make a hypothesis for number 1 and write it onto your lab. Hypothesis number 2, it says, as the drop angle of the object increases, how do you think this will affect the period? And again, the drop angle is how far we pull the pendulum out. So if this is the start point, if we started here with it neutrally buoyant, we pull it back 10 degrees, 20 degrees, 30 degrees, 40 degrees. We're going to try to keep it under 45 degrees for all of the trials, but again, you're supposed to make a prediction. How do you think that's going to affect the period? And then the third hypothesis, which will go with the third experiment, as the length of the string is increased, what do you think will happen to the oscillation period of the pendulum? So we can start with a given length. We might be at 45 centimeters, I believe, is where we're going to start, and then I'll just keep shortening the pendulum, and you guys got to make a prediction. And again, hypothesis, they don't have to be right, it's just a guess on what you think will happen. So we're going to start out at about 45 centimeters, and I'm going to reduce the length of the pendulum, and then we'll just measure the period. So all the data that you have to record here for the most part is just measuring times, which I will show you here in a second. I got the apparatus set up, and I'll go through it, and I'll read the times out to you guys, and you're actually going to record them down. Okay? So for experiment number 1, we're going to start with 2 washers, and we're going to do 3 separate time trials. So I will perform all 3 of the trials for each number of washers, and then you guys will get a time average. And then I'll do the same thing, but I'm going to add 2 more washers, so we'll have 4 washers. I'm going to do time 1, time 2, time 3. You guys will average those out, and then we'll add 2 more washers so that there's 6 total washers, and I'll get time 1, time 2, time 3. You guys will record all of these out, and you're going to average the times, and there will be a place for you to submit all of these answers. You can do it on paper, or I'll have an electronic option for you also, which you'll see in the modules. So we're going to do 5 full oscillations for experiment 1, and then for experiment 2, it's going to be pretty similar. We're going to use a single mass. We're going to keep the length of the string the same, so just put, I think I'm going to just do 4 washers or whatever. I'll just keep the same mass, and I'm going to start at 10 degrees and go to 20 into 30 into 40. So we'll drop it at different angles, and we'll measure the oscillation time for that one also. So that'll be experiment number 2, which will help you answer to see if your hypothesis 2 was correct. And then the very last one, experiment number 3, we're going to use a single mass, but we're going to change the length of the string. So I might keep those 4 washers on there, but then I'm going to shorten the string. I might start at, say, 45 centimeters, and I'm going to reduce. So we're going to move to the experiment. I'll kind of talk through it as we go, and I'll give you guys the data as we're walking along. Then at the end of it all, you guys are going to want to do the conclusion, which is to make a graph that has to do with the period and the length, but I'll get into that here in just a couple of minutes. So let's jump into the experiment, which is right over here. Alright, so here we are at the experiment. I got everything set up, so we're going to go through experiment 1 first. So on your printed out lab sheet, you guys will have data table number 1 for experiment number 1, where we're going to be changing the mass of the washers. So what we're going to do here is we're going to do 3 time trials for 2 washers. So this will be our first set of data going across. Right now I have 2 washers on here. I'm going to pull this back to a set angle, and I'm going to record 5 oscillations, and I'll give you guys a time as we go through. So here will be time 1 for 2 washers. I get my stopwatch ready. I'm going to do ready, set, go. There's 1, 2, 3, 4, and 5. So I stop my stopwatch. I'm going to record my time. I got 6.38 seconds for my time for time 1 for 2 washers. Now I'm going to do time 2. Bring it back to the same height here. Keep the drop angle the same. I'm going to do ready, set, go. There's 1. There's 2, there's 3, there's 4, and there's 5. I stop the watch. I'm going to have 6.37 seconds. So 6.37 seconds is time 2 for 2 washers. Then I'll do the last trial here, time 3. Do ready, set, go. There's 1, there's 2, there's 3, there's 4, there's 5. So stop it. This would be time 3 for 2 washers. I'm at 6.42 seconds. So later on here you guys can do the averages. You can add up the 3 times straight across, time 1, time 2, time 3, and then divide by 3 to get your average time. So now the variable that we're changing for experiment number 1 is the mass, or the number of washers that we have on. So now I'm going to add 2 more washers to this, so we're going to be at a total of 4. So we're increasing the mass here a little bit. I'm going to pull it back to the same drop angle, and we're going to do 3 trials. So here we go with first time for 4 washers. Ready, set, go. There's 1, there's 2, there's 3, there's 4, and there's 5. So stop this. So time 1 for 4 washers is 6.44 seconds. Now we're going to move on to time 2. Pull it back to the same drop angle. Ready, set, go. There's 1, there's 2, there's 3, there's 4, there's 5. So stop this. So this is time 2 for 4 washers. I got 6.58 seconds. Time 2, 4 washers. And this is the last one, so this would be time 3. Ready, set, go. There's 1, there's 2, there's 3, there's 4, there's 5. So for time 3 for 4 washers. So time 3 for 4 washers, I got 6.46 seconds. And again, now you guys can average those 3 trials out to get your actual time average. All right, and then the last, we're going to add even more mass. I'm going to add 2 more washers to this. This is going to give me a total of 6. So now I got to do my 3 time trials for the 6 washers and let it begin now. Ready, set, go. There's 1, there's 2, there's 3, there's 4, there's 5. 6 washers, time 1, 6.48 seconds. So 6.48 seconds, time 1 for 6 washers. Now we're on to time 2. Ready, set, go. There's 1, 2, 3, 4, and 5. So time 2 for 6 washers, I have 6.30 seconds. Then, last trial, here's time 3. Watch. Time 3, ready, set, go. There's 1, there's 2, there's 3, there's 4, there's 5. All right. Time number 3 for 6 washers is 6.44 seconds. So that concludes experiment 1. Again, to kind of answer your hypothesis for this, you'd want to go over and add up all 3 times going across, divide by 3 for 2 washers, 4 washers, and 6 washers, and look at your time averages and see if they increased, decreased, or approximately stayed the same. Okay, so now we're going to break it down. We're going to do experiment number 2, and for experiment number 2, we're going to keep the mass consistent. So keeping the mass consistent, I'll just drop this back. We'll go right in the middle. We had 2, 4, and 6 washers. I'll go back to having 4 washers. But what I'm going to change now is I'm going to change the drop angle. So you can see in the background, I got a 360 protractor here, so I'm going to measure dropping it from 10 degrees and 20 degrees and 30 degrees and 40 degrees. So I'll increase the angle that I drop it. And we're going to do 1 time for each of these trials. And then we'll move on to experiment number 3. So trial number 1. We got a release angle of 10 degrees, and we're going to time again 5 oscillations. So I got to line this up. I'll get this lined up here. Go back. Here's our 10 degrees. I'm going to do ready, set, go. There's 1, there's 2, there's 3, there's 4, and there's 5. So 5 oscillations at 10 degrees. We're looking at 6.51 seconds. So 6.51 seconds for the release angle of 10 degrees. Now we're going to go to 20 degrees. We're going to keep the mass the same. I'm going to go from 10, instead of 10, I'm going to go to 20. And I'm going to drop, ready, set, go. So there's 1, there's 2, there's 3, there's 4, and there's 5. So trial 2, 20 degrees, we're looking at 6.53 seconds. So 6.53 seconds, trial 2, 20 degrees. Now we increase to 30 degrees. So 30 degrees, we're going to drop. Let's see, I'll get this lined up. There's 10, there's 20, there's 30. So I'll do ready, set, go. There's 1, there's 2, there's 3, there's 4, there's 5. So 30 degrees, this is trial number 3, 30 degrees, our time is 6.58 seconds. So 6.58 seconds, release angle 30 degrees, trial number 3. And then the last and final for experiment number 2 is 40 degrees. So this will be trial 4, we're going to do 40 degrees. So here's, let's see where we're at. There's 10, there's 20, there's 30, here's 40. So here's 40 degrees. I'm going to release, ready, set, go. There's 1, there's 2, there's 3, there's 4, and there's 5. Stop the watch. So this is trial number 4 at 40 degree release angle. The time, so this is trial number 4, released at 40 degrees, and the time is 6.60 seconds. So 6.60 seconds, release angle 40 degrees, trial number 4. All right, if you guys look at the next experiment number 3, what you have here is we're going to do various trials. We're going to do trials 1 through 6, and we're going to be changing the length of the string. So the length of the string right now, measured from the pivot point to the center of the mass, is at 45 centimeters is where we're starting. So this again is from the pivot point to where the center of the mass is. I'm measuring 45 centimeters. We're going to do as we go down. So I'll read those as we go. But this is trial number 1, 45 centimeters. I'm going to pick it up to a given height. And do ready, set, go. So here's 1, here's 2, here's 3, here's 4, and here's 5. So I stop this. So a 45 centimeter length of string, the time is 6.34 seconds. Now trial 2, I'm going to shorten the string. I'm going to put a few wraps in here. I'm going to shorten this up a little bit. Okay, so for trial number 2, I've now reduced the length of the pendulum to 38 centimeters. We're going to drop, we're going to do 5 oscillations. Here we go. Ready, set, go. There's 1, there's 2, there's 3, there's 4, there's 5. So I stop the stopwatch. So trial number 2, 38 centimeters, we got 6.19 seconds. 6.19 seconds. Trial number 3, shorten the string again. We're at 31 centimeters from the center of the mass to the pivot point. So this is trial number 3, 31 centimeters. I'm going to pull the pendulum back. Be ready, set, and go. There's 1, there's 2, there's 3, there's 4, and there's 5. So, trial number 3, length 31 centimeters. Our time for the period of oscillations here is 5.42 seconds. So 5.42 seconds, 31 centimeters, trial number 3. Trial number 4, I'm going to shorten it up again. 26 centimeters. So 26 centimeters will be trial number 4. So trial number 4, 26 centimeters. We're going to get to time for 5 oscillations. Ready, set, and go. There's 1, there's 2, there's 3, there's 4, and there's 5. So 26 centimeters, trial number 4. We have a total time of 5.01 seconds. So 5.01 seconds. Trial number 4. We'll shorten this again. You're right at 20 centimeters for trial number 5. So trial number 5, 20 centimeters. We'll do the time for 5 oscillations. Ready, set, go. 1, 2, 3, 4, and 5. I got my time for this one. So trial number 5, 20 centimeters. We're at 4.21 seconds. 4.21 seconds. And then the last trial here. So here we are at trial number 6. From the center of the mass to the pendulum point here, we're looking at 14 centimeters. So we got her shortened up here about as far as we can go. We're going to do 5 oscillations. So this is trial 6, 14 centimeter length, and ready, set, go. 1, 2, 3, 4, and 5. There it was. 3.57 seconds. So that would be the total oscillation for trial number 6 with the length of the string at 14 centimeters, and our total time is 3.57 seconds. Okay, so we're going to go back, we're going to take a look at just laying out the graph. You guys are going to have to graph all of your data from experiment 3. We're going to be looking at the length of the string relative to the period of the pendulum. Alright. Alright everybody, so we should be done with experiment 1, 2, and 3, so you should have recorded all of your data in here. Again, make sure you record all of your time averages. So adding up 3 times across here to get your time average for experiment 1. Experiment number 2, you can just compare your data as we change the release angle. There's nothing to average because we only did 1 time for each trial. And then for experiment number 3, we changed the lengths of the string as we went through, and we should have all of your times and seconds over here. And the last thing you're going to do is you're going to take all of this data and you're going to try to make a graph. So the graph wants the length of the string on the x-axis or the horizontal axis, you want the period on the y-axis. So when you go to lay your graph out, it will look something like this. You're going to have length across the bottom in centimeters, and you're going to have period up the vertical side in seconds. So again, try to find a scale that will work for the graph. Our largest length of string was 45 centimeters. So you can maybe do 5, 10, 15, 20, all the way up to maybe 50 or so. And then our period, don't do every line as 1 second, because obviously our largest, remember your largest times here for your periods were still just over 6 seconds. So if you take a look at the vertical axis here, you could at least do, 1, 2, 3, 4, 5, 6. You can probably do every fourth line maybe as 1, and you should be able to pretty much get everything on the graph. So plot that out. There will be questions that will pertain to the shape of the graph that's produced, questions that also go along with asking specific questions about the data that were received for each trial. And again, if you want to handwrite this and personally submit it to me, perfectly fine, I will grade it that way. Or you can take a photograph of it, email it to me, but the preferred method for submission would be to open up the module that it'll give you the digital submission for the Pendulum Lab, and there'll be some multiple choice questions in there that will pertain to the data that we collected. So that's about all we got for today. So thanks a lot, folks. This video lab should be concluded, and if you guys have any questions, please feel free to contact me and we'll go from there. Thanks a lot and have a good day.